Alright, so let's see, I'm going to demonstrate how to use the Netbeans ROS Pack for the purpose of building up a ROS workspace. So I've got a workspace here that a colleague of mine has been using, and it's got 6 different packages in it, and so I want to basically replicate this workspace within my own user account. I've already gone out to the web and located the various places I'm going to pull code down. These tabs represent the different Git repositories that I'll be accessing to pull the code. And I'm starting from scratch, so I've just got NetBeans that I've installed. I don't think I've installed the plugins for ROS, so let's give it a shot here. So fire up NetBeans. First thing I'll do is see if ROS plugins are installed, and it looks like it's a brand new install of NetBeans. So right now, no anonymous data. Let's see, and so if I try and create a new project, let's see, I don't have ROS available anywhere, so that means the plugins are not installed. So I'll have to go and get them. So NetBeans ROS Pack. That's where it is. I'll go ahead and download it. So I have 8.2 download. This downloads to my downloads folder, so I'll go to the downloads folder. We'll extract it in that location. That creates this updates folder. These are the 3 NetBeans plugins. So we go to Tools, in NetBeans, Plugins, we go to Downloaded Plugins, Add Plugins, we find our location that we just extracted them to, Downloads, Updates, we select the 3 plugins, we press OK, and then we accept all these license agreements. So install, I accept all of the license agreements, and we're gonna restart the IDE. Now I've got my NetBeans plugins for ROS installed. Alright, after that I'm gonna have to create a ROS workspace, a ROS NetBeans project that is a ROS workspace. Okay, and so there are a couple of things about NetBeans that we have to, I'm gonna have a C++ project, and so I'm going to make sure that we've got C++ enabled here. So C++, it is not enabled, so I have to activate it. So that was, I go to Tools, Options, and then I go to the C++ tab to make sure that NetBeans is installed with C++ support. It's not activated. Click Activate. It's activating the C++ modules. That's sort of a necessary ingredient. It's found all the tool chain. Oh, I've even got some Fortran compiler. Wonderful. This is all good. I hit OK. Now, for me, let's see. I'm running Kinetic, and Kinetic is one of these things that has OpenCV, like a custom version of OpenCV compiled into it. I want to use those includes and headers, so I'm going to set this actually up in my code assistant so that when I start to navigate through the code I can use those include files. So I'm going to add, and I've already got ROS installed, so under the opt ROS Kinetic, I'm going to add the opt ROS Kinetic include. That'll give me code assistance for all of the Kinetic header files. And then I'm going to actually also, and I wouldn't do this in the latest version of ROS, which is Melodic. Melodic, we're using the standard OpenCV install, but Kinetic has a custom OpenCV install, and I want to use those headers, so I'm also going to include the OpenCV 331 dev folders. I'm going to put them up at the top so that they supersede any local OpenCV that might be on this computer, and then I'm going to repeat that for both the C++ as well as the the C compiler. And so we'll put these to the top of the priority list. Okay, so that should get me going with pretty good code assistance in terms of being able to navigate through header files and make myself all the API will be available to me that I'm needing for my code. Hit OK on this. Now I need to create my ROS project. So I press create a project. Now I've got this ROS project. I go next. This is going to be for a Turtlebot, so I'm going to say Turtlebot UNCC slam. That's good as name as any. Go ahead and create my ROS project. It's going to create a ROS project, which is enabled by the plugins, but it also creates a second area here. This is a C++ project. That C++ project is a child project of the overall ROS project, and it's actually the project that manages the workspace. So when you want to work with the C++ capabilities of NetBeans, you work from this project here. When you want to work from launch files and ROS-oriented things, you work from this tree of nodes here. First thing I need to do is I need to configure it to recognize my distribution. So its default is Indigo, which is when I first wrote this plugin. So I'm going to set it up for Kinetic, which is what we've got installed here. And there's a makefile here that basically runs the show. This makefile has got all sorts of things in it, but basically it does all of the building processes that you would normally do in a standard ROS workspace, and it automates that through NetBeans. Now that we have our basic ROS workspace, well, we can build an empty workspace. I'm not sure exactly what that does, but go ahead and look at what it does. And so the point being, if you go to the window output area, you can see the standard ROS. It's going to invoke catkin make, and it's going to, in this case, invoke it with the build make of release. Now, if you go into the makefile, this makefile that's here in the project, you can change from release to debug and actually get different kinds of behaviors from your compiler, so that you can do some ROS node debugging, things like that. So let's see. Without further ado, let's go ahead and pull these packages. So we've got, let's see, what's first on the list? So let's do it. So bot PID Kabuki is over here. So I think that's here. Let's pull it this way. So you can copy the HTTP. Go in here, and then we'll do a git clone. This is where we clone it from. This is my credentials. At least I think they are. Might have to guess here. So hopefully that'll get through. Okay, wonderful. So it's going to pull from master. Now the thing is, you have to make sure that it goes into the source folder of our ROS workspace. So it's going to go in here, in the ROS workspace, into the source folder. Okay, pull it into there, or clone it into there. Wonderful. So inside here we now have our first ROS package, which is bot PID Kabuki. And of course we could go ahead and build and see if this builds for us. Looks like we might be missing something. Params, so it's got to invoke some, maybe we don't have Turtlebot packages, but sometimes ROS doesn't build its own parameter files, so it's a dynamic reconfigure situation there. And we'll come back to that. So let's see, we've got bot.pid kabuki loaded up and all of its source files there, which I might have to work with to get it to properly compile. But let's pull the other stuff and hope maybe one of the other things will satisfy its needs. What's next? DVO Slam. Okay, so DVO Slam is, I think it's from one of these repositories. Here it is. We'll get the address to clone it from. We'll do a team. Now, I'm already selecting a Git repository. I actually like to see the version, the branch that I'm working from. And so I turn on the versioning labels, which will appear right here, so I'll know which branch I'm working from. So this is the master branch. But if I want to pull another repository, I have to select a non-active Git repository. So I'll go back here. Now I can clone. I'm going to clone from here. This is a GitHub location, so it's just, let's see, let's get the kinetic devel. That sounds like the right thing to get. And it'll clone it to the right place. Okay. And actually, DVO Slam is a package, is a folder of packages. So now we've got that. I guess I can start that. That'll take a while to compile, so I'll start that off. Let's see. RGBD drivers UNCC. All right, let's go ahead and get that. That is. All right, here they are. That's something on our university server. So we'll do team git clone. And this is a university deal. So this is from our visionlab.uncc.edu/var/lib/git/source/active/ whatever the name of this thing is. RGBD drivers UNCC. Okay. Then I'll have to, well, hopefully, I don't know, maybe this password, I don't think this password is right, so I'll type in my password. Next. My password did not work. This needs to be an SSH connection. Okay, there we go. All right. I just agree to allow it to set up the credentials for my SSH connection to the server. And now I've got RGBD drivers. Now let's get ROS RGBD surface tracker. I think that's from the same university server there. So team git clone, and then since it's from the same place, RGDB surface tracker, is that? So yeah, it's got the same name, so I think this is all okay. Maybe it didn't. ROS, our RGBD surface tracker. All right, so there we go. And now we have that. Okay, so let's see. This is still complaining about something. Just keep hitting it with compiles in the background while I download stuff. And let's see, what's next on the list? Set point publisher. I think that's a GitHub thing. So set point, here it is. So clone this. Okay. Team git clone. It's a GitHub thing, so I don't need any credentials. And now that's in my workspace. Okay. And finally, UNCC RGBD Slam. Okay, so I think this comes from a university server. here it is. So we will get it from there. Team git clone. Let's see. Now, what's the name of it again? I don't want to try and get this right this time. Oh, all right, fix this up. And okay, so now I've pulled out my 6 repos, which since there's 4 in here, that's 5, 6, 7. So I've got 9 packages in my workspace. So now the process of getting all these packages to build sort of proceeds. So I'll give it a shot. And you know, this is a work in progress, but you know what, something else I kind of like to do here too is I like a couple of plugins. So one thing that I really like is there's a Git toolbar, and so I install that plugin sort of almost instantly, as I am now, and so that'll give me make all of the Git operations that I typically use right at my fingertips. So now I've got this Git toolbar here, so if I go into some project and I say, hey, I change this and I want to push or pull, this icon is pull, this icon is push, and you just click it and it gets done, and that makes life much easier for me. So let's see. We've done all this pulling. So the output window has these things for me to look at. And I'll close all these things. Now we'll just look at the compile window. And the compile window needs UNCC ODOM. UNCC ODOM is not here. So it looks like we need another package. Well, I happen to know where that package is. So of course, so that package is here on our Vision Lab server. So we'll just get it from there. Let's see. Go to there, git clone. That's all we need. Okay, so let's hope that we've got what we need here. ROS G2O messages is needed. All right, fair enough. So these are the additions that we've recently made. Of course, they're all here on G2O, so we'll just pull them down. Okay, let's see how we're doing now. And so you can double click this window if you just want to see a little bit more accurately what's going on. And it looks like it's trying to do build things. It's still having trouble with the bot PID Kabuki. Set up a custom path. Params.cfg permission denied. Well, I wonder why my permission is denied to that. So go to home and Netbeans projects and put this in the list form. Change this a little bit. I don't like how that works. Let's see. So here's our source space. The problem seems to be somewhere down in here, and but setup custom path is something that's inside bot PID Kabuki, and it's trying to access CFG params .cfg. So I don't know why this might be a problem, but maybe it needs to be executable or something. Permissions. Everyone can read and write. Oh, we need to execute it. Maybe that's the deal. Sometimes ROS needs that kind of stuff. Double click this to collapse it. Double click that to make it go away, and we're back on our merry way. Well, it looks like that sort of helped things along here. I mean, sometimes things get a little wacky. But now it's compiling, and this stuff is going to take a while to compile. I just pulled, I don't know, I guess it's 11 different packages, and these packages have a lot of stuff going on inside them. A couple of things, you know, you can do debugging. You have to set up the environment. If you have questions about that, that's fine to send me an email or something. But you really kind of need to go in and consider, if you're debugging, you have to change your build type to debug within the makefile, so you have to actually edit the makefile. I haven't had time to make that something configurable. And then you have to go down into your C project. In your C project, you have the play button, and you have the debug button, and you can actually do things there with debugging. Now you also should have code navigation if you're going through your code here. So I don't know what's in set point publisher, but hopefully there's some C code. Looks like it's Python code. I need to install a Python module to make that look pretty and to work with that as if it were compilable. So I'm going to focus on C++ for now. So here's some C++ code. It's highlighted. You should, when it does go around and build up your code assistance, you'll have code navigation, and so code assistance, you can reparse the project, and that will, I mean, right now I'm sort of tormenting the system with the compile at the same time, but that will give you code assistance on things. And code assistance works best when you build a debug version. It actually analyzes the built targets. You really want to build targets and run them through the IDE to get the best code assistance. I think that's all I want to tell you about right now. Let's go back and check on our compile process. Yeah, it's just cruising along, but it will, again, it will take some time. So we'll just stop the video right here, and I'll post this up on YouTube. Thanks for your time, and I hope you are able to use NetBeans to make your coding experience more efficient and to do new things that you couldn't do previously. Thanks.